Okay, so my name is Ewa Gasperowicz, and I'm a developer programs engineer in Google, and I'm super hyped that I can give you this presentation here in Wrocław. Wrocław is, I think, one of my favorite cities in the world, so I'm really honored that I can be speaking here at this event. This talk is about progressive web apps, and in particular, the service worker and caching. These are two technologies that are part of the foundation the progressive web apps are built on. How many of you heard about progressive web apps before? Oh, perfect. So we're safe here, at least. Okay, I think those two technologies, service worker and caching, when used in the right way, can offer a tremendous advantage for you while building your web apps, especially in terms of resiliency and performance. So today I would like to share with you how I approach designing a service worker flow, and in particular, what kind of questions do I ask when designing the service worker strategy in my own projects. So, progressive web apps, as you all probably know, are websites and web apps that work smoothly on all kinds of devices and have similar capabilities to native apps on mobile. And before the progressive web app movement and progressive web app world, our options in terms of web apps were pretty limited. In particular, the user could be in only two different states. They could be online, and then the web and internet kind of worked, and in the offline mode. And then even opening your browser was a useless task, right? Like nothing worked offline. So the life was nice and simple, and sometimes useless. Actually, there is also a third state, which I call Li-Fi. Have you heard about Li-Fi before? Well, Li-Fi is the state where your device, for example, a phone, tells you that you're connected to the network, but actually the internet is not working, either because the network is too slow, or because it's patchy, or because IP DNS issues, and so on. It's this state where some of the resources work, some don't, and it's somewhere in between the state where you're connected and when you're offline. It's like a Schrödinger cat of connectivity. You're connected, but not really, right? And this state is actually very dangerous, as I will show you in a moment. So everything in the pre-progressive web app world depended on the network. If there was connectivity, the user would get a website. Easy. If there was no connectivity, the user will get a dinosaur or whatever your browser decides to display when there is no network connection. And then if you are on Li-Fi, usually what you get is a mess, which means some of the resources load, some don't, and the experience can be very broken. Let me show you an example. This is a small e-commerce site that I built recently. So when you're offline and there is no service worker and caching enabled, it is a nice, sleek experience. You see all the content, all the pictures. You can buy stuff on the websites. It's a rich experience and everything. Now on Li-Fi, it might happen that you don't get a dinosaur, but you get a broken experience. For example, the images might not load, and then the site looks broken to the user, damaging the trust the user puts in your website. It might get even worse. In this case, the HTML for my page loaded, but then the connectivity was broken, and the styles did not arrive. And because of that, the site is actually unusable on mobile, and it's really damaging the user experience and the user trust. It's more dangerous than the real offline experience, because when the user sees an offline page, like a dinosaur, they blame the network, and they maybe blame the browser. If they see something like this, they're more likely to blame your site and never come back. Broken experience like this leads to users' exit, and you cannot be sure that they will ever return again. Fortunately, service worker and caching API can mitigate that risk to some extent. And this is an important distinction. Usually when we think about service worker and caching API, we think, okay, this is to make my app work offline. But actually, it's also for these Li-Fi scenarios to make your app more resilient. That generally the content you deliver is delivered over the network, but in case there's a glitch, you have a backup plan in the caching solution. So this is a page my colleague, Jake Archibald, made some time ago to track whether the service technology is ready. And he was super, super happy sometime back this year to change it to one single statement, yes. So Service Worker is ready. It's implemented in all modern browsers these days, which means when you're preparing an architecture for a new project or for a new site, you can consider Service Worker to be mainstream and core to your architectural choices. It's not only a progressive enhancement at this point, but it can be really a big part of your site's architecture, and you can take advantage of that to provide better offline capabilities, but also better performance and resiliency for your web apps. Now, what exactly is a service worker? Service worker is just a script. It's just a JavaScript script that serves as a proxy. It sits between your web page and the network and allows you to control how your web page is connecting to external resources. It has some more uses than that. For example, it's necessary for push notifications and background sync. But in this particular talk, I want to focus mostly about the network connectivity and the resource management in Service Worker. When there is Li-Fi and the network connectivity is not as we would like it to work, Service Worker can give us a choice to fetch the resources from other source, for example, from cache, as on this example. So, if caching allows you to achieve better performance and better resiliency for your app, maybe we should just cache, right? Let's just cache everything. And actually, it's very easy these days. You know, when you check generators like for React apps, or for Angular, or libraries like Workbox, it's very easy to cache, just dump to the cache your entire site. For example, if you were using Workbox libraries, which is a very nice library to work with the Service Worker, this is all the code you need to really dump everything from your app to your cache. You add these few lines to your app, and bam, you cached everything. And there's a disclaimer, don't do that. That's probably not the best idea. Why? Well, this is a graph showing the size of the app for Twitter. Some time ago, Twitter implemented their web client as a progressive web app. And you can see the sizes, the relative sizes of the clients Twitter was offering. So iOS app takes a lot of storage to install. Android app also takes quite some storage. And then their progressive web app was much smaller. And this is a good example of one of the advantages of the progressive web app. Because we offer, very often we offer progressive web apps for the long tail of the internet, and you want users to be able to install many small apps on their devices, you don't want to overwhelm their cache. You don't want to download everything for the user. You want to keep progressive web apps small, and therefore you need to be thoughtful about how much space you're going to use on the user's device. Especially that web is slightly different than native in this regard. In native applications, what is happening is you kind of download the package straight away, and that's the size of your app. In terms of web applications, we rather work with URLs, right? Like we think about this is my site, this is a coherent unit, but actually the internet doesn't work in terms of site, it works in terms of URLs. So for example, if you check, I don't know, in DevTools, in the network tab, how much your page weighted, you actually know only the weight of that one single URL. If you want to provide a really smooth experience for the user, usually you're caching at least few URLs. Or if you have a single page app, at least a few views, right, which are kind of an equivalent for the URL. So you need to keep that in mind, that you need to kind of realize what's the size of your app in terms of a gathering of URLs, rather than just a single entry point. So how to measure that? As I told you, you can't really rely on the network tab to tell you, like, okay, this URL downloaded, I don't know, 500 kilobytes of resources, right? In order to check the overall weight of your app, you can do it like this. In the DevTools, in the application panel, like here, you go to the clear storage. And for a long time, I didn't realize that's where I check the storage, because I was afraid of hitting the button that is called clear everything. So don't be afraid. Click it. Nothing bad will happen. It will just show you the stats. And only then, at the bottom of the page, you can actually clear it. I know it's not ideal naming. Hopefully, we'll change it at some point. But as of now, that's how you check it. And this is checking the cached resources for all the URLs of your app that the particular user on this browser visited, right? So for example, when you're planning to check how much your app weighs, you can prepare a kind of user scenario, like how you expect the user to navigate through the page, do all those navigations, either manually or automatically, and then check, OK, that's how many resources it actually downloaded after visiting many URLs or many views. And the important thing is this value here, this size changes over time, because caching might happen at the beginning, like at the installation step, but also later on. So for example, here, when I just opened the page and nothing happened yet, my app is like nothing, right? Once the service worker gets installed, it takes some storage in my cache. So the app is already growing. And then when it downloads even more resources, it's at 154 kilobytes here. And this means that at this moment, my home page will work offline. No other views and no other URLs will work offline. So this is just the weight of that particular URL. If I go and click through, all the resources I have on this page, all the categories and so on, I end up with 1.4 megs. So you can see this is a big difference in the outcome of measurements depending on which moment you choose to measure. So you need to plan for that carefully. And this is a very small app, right? There are like 5 categories, maybe 100 products. For a big site, like, I don't know, Amazon or something like that, you can imagine that those numbers over time can really add up. So you need to be really careful about what you put in your user's cache. Be mindful of your resources and respect your user's bandwidth and also their storage. And how to be mindful about it? Well, there's this saying, hope is not a strategy. So it's better to have a really good plan rather than just, cache everything and hope for the best. And that's my first tip for you. Before you even write one line in your service worker, think through your resources and figure out how to design a proper flow instead of just jumping in and, caching random stuff just to have something working. OK, so how do we go around designing the service worker flow? Well, as I told you, service worker is kind of a proxy that sits between the website and the network. So in a natural way, we have 2 parts of the service worker flow or strategy that we need to think about. There is the caching part, which means where service worker gets its resources from, how it communicates with external entities. And then there is the serving part, which means how service worker is sending the content back to the website. Let's start with caching, right? With getting those resources into your browser and into your system. So when you consider caching, there are a few questions. Okay. There are a few questions you need to find an answer for. First, what to cache. The second is when to do it, when is the right moment. The third one is how to update. And there's actually a fourth that is more important than any other ones, which is what not to cache. That's a really important thing you need to figure out at the beginning. And then when it comes to answering the question what not to cache is just don't cache trash. We tend to put trash on our websites like unnecessary resources, unoptimized images, and so on. So just before you even start thinking about caching, cut the fat, optimize your website, make it as lean as possible so that you don't end up pushing resources that are not exactly necessary to really small storage of some underpowered devices of your users. Generally, it's always a good idea to optimize images, to remove unnecessary code, like, for example, unnecessary libraries. This happens a lot when you start a project, you add a few libraries to it, and then 1 month later or 3 months later, you end up changing your approach. You stop using those libraries, you use other ones, but they're still in your bundle. So you need to be mindful of that and have some auditing process set up to avoid this type of scenario. Non-essential fonts that you download with your app, but you end up never using or using very rarely, are also an example of unnecessary resources. So just cut this fat before you start optimizing for caching, and then you realize it's much easier to handle the resources after that step. There is a link, PWA-audit on Bitly, that you can follow the guidance there to see how you can prepare your app for caching before you actually implement the service worker. Okay, so that was what not to cache. Now let's talk what actually we want to put in the cache. And the truth is that not all content is created equal. What do I mean by that? Well, there are important things on your website and even more important things, right, usually. So here's an example what I mean. This is a Women Tech Makers website that I worked on some time back, and it's a really rich visual experience. It's lots of imagery, it's very graphical, because it needs to kind of invoke the emotions in the user and so on. And my task was to enable offline experience for this. If I wanted to dump all of that imagery into the cache, that would really overflow pretty quickly. So I needed to be really mindful about which of those images I put in the cache and which I don't. And I wanted to be as not arbitrary about it as possible. So I try to strategize around the images. If there is no images, the site is unusable. So for sure, I need to cache at least some of those for the offline experience. Let's see what kind of images we have on the page. Well, the ones I highlighted here in yellow are navigational and action images. It means if they're not there, the user is not able to perform an action on the page, which means it disables some of the feature for them, which means they're super important. And probably I want them to be there all of the time without any condition. Now, the orange one, like the Women Tech Maker logo, are pretty important to me as a business. They create my brand identity, they create the bond with the user, so I call them, they have a priority. I want them really to be on the page. Now, the blue ones are the ones that are responsible for this rich visual experience. I call them decorative. They really add to the value to the site, but if they're not there, they don't really break it, right? The site is still usable, the user can still read the content, so it's not the end of the world if some of them are missing. Now, the green ones are interesting ones because I call them informative, which means apart from the decorative function, they also convey some information in them. For example, here, they are logos of particular technologies or sponsors and so on, right? So most probably I don't treat them as priority images. I don't want to cache them all, but if I can convey this information in some way, it would be still nice, right? Now, this is how the page behaved once I implemented the caching. The yellow ones, I just made them inline. They're small, they're icons, they're SVGs. It's easy to just embed them in my HTML and be done with it. I don't even need to come up with caching strategy for those. If my HTML is there, they're gonna be there. Done. The red ones, priority ones, always in cache. Push to the cache with this initial install load, pre-cached, and always served. Blue ones, cached at best default, which means I cache as many as I can, but the ones I can't, I don't cry over them. You can see that the image in the banner is missing and one of the below images are missing, but it does not break my site. And then the green ones, they have a fallback, which means I kind of display a fallback image. I don't have the real image there, but I can still convey this information that was contained in the image in the textual form. So you can think about the content on your website and strategize around it in a similar way. Figure out what function this particular content plays on your website and adapt your strategy accordingly. And most importantly, be selective. Don't push everything to cache. Push stuff that really creates the core of the experience for your user. And depending on how much free space you have left, then you can add extras on top of that. So that was what to cache. Now let's talk about when to do it. That's one of the next decisions you need to make when designing the service worker. Generally, we have 3 options here. You can either pre-cache, which means like during the installation step, make it like a package, like in a native app. Runtime caching means while your user is using your app, you can download more resources and cache them during the runtime of your app. And then caching on demand is similar to runtime, but with this difference that here the user explicitly asks you, like, please save this for me for later, for offline. For example, because they want to read an article later on when they have low connectivity. So in order to understand or maybe visualize better where those points are, I'll show you a quick graph about service worker lifecycle. So first, when the service worker is downloaded to your browser and to your app, it gets an installation step, right? After the installation, it's installed, it activates, which means it starts to control all the tabs where your site is open in the browser. And then the next step is it's running, which means they can answer for the fetch events from the website and for the messages from the website. And here are these 2 entry points I told you about. The first one is the installation step, that's for pre-caching. And then the second arrow is for runtime caching and on-demand caching. Pre-caching is really good. If you have a reason to cache things ahead of time, it's really good for performance, because it means your resources end up in the cache before the user is actually needing them, right? Which means once they do need them, the answer is very immediate. It takes as long as opening the cache. So you're saving the time on the whole network trip. It's very good for static assets like scripts, style sheets, and so on, right? The important thing is they need to be versioned in some way, because you need to be able to update those resources every now and then. If you mess up versioning of your files, you might end up with the unstable state of your application. That's why it's better for static resources than like navigational requests, like for example for the blog post content and so on. Important thing is this step happens at installation moment, which means those resources will only update when the service worker update. Here is an example of how to do it on installation step, and you can see that all the resources here have like content hash embedded in them, and also the service worker version is signed. It means those resources will get re-downloaded only if their hash change and the service worker gets a new version, right? So that the browser knows, okay, I have a new version, I need to kind of pre-cache all of the resources I had so far. So that's the tip number 4, use correct versioning, because if you don't do that, you might end up serving stale content to your user. Generally, pre-cache is good because it's easy, and there's a lot of automated tools, how you can prepare this versioning manifest and so on embedded in the service worker, so it's relatively easy. Also, it's harder to get out of sync than with runtime cache, and it's good for performance. It's not good for a whole site because, as I told you, you don't want to push everything on the installation step. Also, if you download a lot of stuff during the installation step, and you happen to trigger this installation step before all of your kind of content appeared on the page, you create network congestion, and the rest of your content that the user actually needs right now might be delayed because of that, right? So you need to be mindful of that, and it's really hard to update unversioned assets. So it's good for the stuff where you can attach a hash or some versioning information. Now, runtime caching happens when the user is using your website. So it has this advantage that you can use this information to adapt your caching behavior. For example, you want to cache only the pages that the user already visited, right? You can't do that in pre-caching, because on pre-caching you don't know what user is going to do in the future. But when you do runtime caching, for example, when the user visits the URL, that's when you download it to the cache, because there is, for example, high likelihood that they will go back to this content at some point. It's better for non-revisioned content than the pre-caching, and also it updates independently of the service worker, so you don't need to change your service worker version to go and refetch the content during the runtime cache. And here's the example. You see that I'm listening in my service worker for the fetch event, and when the fetch event happens, I do two things in parallel. I go to the network and fetch the content and put it in my cache. That's this caching at runtime. And at the same time, I send this content back to the page because, well, that's what the page requested, right? Pros and cons. It updates independently of service worker. You can cache in response to user behavior. So that's the advantages. The disadvantages are that it's not as efficient for the performance, because if the resource is requested first time, it's not in the cache, right? So only on the second kind of try, you get this benefit of caching this. Also, very important disadvantage to me in particular is that site storage grows over time. As the user navigates to new content, you keep adding stuff to your cache, and sometimes it might get out of hand. So in order to do that, you can mitigate it with limiting the number of entries you store in your cache, cleaning the cache every now and then, and setting appropriate expiration policy. That's the example I showed you before with the e-commerce app, right? This is the homepage cached, so only this one URL is cached. If I navigate to the next view, which is accessories page, my cache takes more space now, right? If I go to yet another category and I use runtime caching, my storage space grows even more, and so on, right? So you need to be mindful of that and know how to measure the size of your app before you blow up your cache. So just be mindful of that, and while developing your app, control the size of the cache you're using throughout the kind of lifespan of your app, not only on the initial load. Okay, now that was the caching. Now it's the serving, like how the service worker is actually responding to the requests from the website. Generally, when designing this part, we have three most typical options. First of all, the content can come from network, as in usual. It can come from cache, like with the caching. And the third option at the bottom is, I call it custom logic. Because service worker is just a script, a JavaScript script, you can have any logic you can put in normal JavaScript file. For example, if you have isomorphic JavaScript on both your client side and your server side, you can use the same templating engine that you're using in the backend in your service worker. And for example, store in cache only parts of your website, like header, footer, and then the middle section, and actually glue it together in service worker and send it to the page. So those are three options you generally have. And depending on how you combine, these different options, you can end up with different strategies. Here, I list only the most popular ones. They're actually implemented in the Workbox library I mentioned before. And if you want to read more about them, I think the names are pretty self-explanatory, like cache first goes to cache, and only then to network. Network first is the opposite, and so on. But if you go to Workbox documentation, you can read more about them. And also, if you go to Workbox source code, you can actually see how to implement them in JavaScript in case you want to play around with it. Here are some heuristics. I wouldn't call it a proper measurement, but heuristics about the potential performance implications of using different strategies. Always like for optimistic scenario where the content ends up on the page, and the P is like pessimistic scenario. So in case of cache only, it's pretty nice because both optimistic scenario and pessimistic scenario is really fast. You get your content to your page very fast. The disadvantage is, if this content is not in the cache or it's stale, the user will never know there is new content on your server. So you can do it only with the resources that you're 100% sure they won't change in future. For example, if you have a versioned hash in your CSS, you know that this file will never change. If it changes, the whole URL will change, right? So then it's a good strategy for that. Cache first means that the orange bar, it's like when the logic goes to the cache first and checks. If it's there, that's the optimistic scenario, it goes to the page fast, but if not, only then it starts going to the network. So it's actually longer than the network only scenario. So you also can take into account here things like what type of user you usually have, or if your analytics tell you what kind of bandwidth usually your users are using. If they're on very fast network, you expect them to use browsers on desktop. Maybe you should design your serving strategies around network first type of strategies. And if you expect your users to be on low-end devices on low connectivity, you should maybe strategize around more cache first scenarios. Stale while or validate is an interesting option because it means that you first go to cache, and you, at the same time when you return stale content, that's why it's called stale, to the browser, you also check, by the way, server, do you have a new version for me? This is nice because the response type is really, really quick, but also the fresh content ends up being served to the user, sometimes on the second load only, because first it gets stale and only then the fresh content arrives, but at least the user is not stuck with the old content like forever. Custom handler means that, well, you can actually combine any of this logic in any way you want. For example, here you can see that I'm using the cache first strategy from Workbox, so I'm trying to fetch an image from cache. So I register this route, I try to handle it, but if it doesn't happen, and I catch an exception, I say, well, serve this fallback image instead, right? So you can mix and match, and Workbox gives you nice options for that, or you can implement it entirely on your own as well. So let's go back to our images, right? We said we have 4 types of images, and we have like different strategy in our head. Now the question is how this translates to particular strategy choices in Service Worker. The first one I already explained to you. I embed it into my HTML and I'm done with it. No caching involved. Now, the priority ones, I want always to be there, and I don't expect them to change. My logo will change pretty rarely, and if it does, I can change its name. So I use precache and root, which is just a shortcut method for precaching on installation step, and then serving always from cache. Now, the decorative ones, I cache at runtime, which means I cache only images that the user actually accessed at some point. And I also put a limit. I limit the how old the images can get in the cache, and the max entries, how many I can store, which means here I store maximum 50. And if the user accesses the 51st image, I evict the oldest one, right? So I never have more than 50 in my cache, so therefore sometimes some images will be missing, but at least it's something, right, for the user. And here is a custom handler for the informative images. Over here you can see that I'm using some custom logic in my service worker, which means I'm trying to get the image first from cache, but if it's not there, I actually use the alt attribute on that image in the HTML to generate the text on the fly, right? And I end up with something like this, TensorFlow, speechless, a book apart image. So you can really put a lot of customization in your service worker, and a lot of interesting generation scripts can happen over there. So, just you need to balance this freshness versus storage versus speed in your app to achieve the best reliability. And unfortunately, there is not a single silver bullet there. Every now and then, me and my colleagues, we argue that there is. Like, every now and then someone comes over and says, like, I found it. I found a strategy that works for all WordPress sites, and then it always appears there are exceptions and corner cases, so not so far. But if you find one, reach out to me on Twitter, and I'll be very happy to discuss it. Very interesting. So just to sum up, in order to design and have a strategy around your service worker flow, you need to be mindful of a few things. Have a plan. Don't go blindly into just implement service worker and hope it does the right thing for your site, because it can actually also damage your performance if you do it the wrong way. Cut the fat before you cache anything. Like don't cache trash. Be selective about your resources and adapt your caching strategies to different scenarios. Use content versioning. This is very important. If your content gets out of sync, you will end up with broken pages for your users. Control the size of your app on the site level, not on the single URL level, and just balance speed versus freshness versus reliability. If you manage to do that, you can really offer a really great experience to your user. And it's not easy, but there are libraries to help you, like Workbox, so check it out. And maybe with the help of right tools, you'll find it easier to achieve the right goal. Thank you so much. And if you have any questions, we can discuss after the presentation. Thanks.
So would you recommend to, this progressive web applications are for web, right? But would you also recommend that for building like a mobile application? So let's say I will build like really responsive website and then put it on the web view on like Android or something. And then I will cache the whole application. So it will, at the first run, it will just fetch all the resources, and then people will use it like a mobile application.
So people have different approach to that. It's a bit personal. My approach is you should always adapt the technology to the goal you want to achieve. If you want your app to be accessed like native app and behave like native app, and the user to interact with it like native app and install it like native app, then just write a native app rather than, because usually when people go with this scenario, it's because of the the talent they have in the team, because they already know how to write web apps, so they package it as native apps. I think it's better to invest in the native technology. The progressive web apps are especially good for skipping the installation step, right? Like it's very seamless for the user. They just open the website, and next time they open it, it just works for them. Or they save it to the home screen, which takes, I don't know, like just not even a second, right? They don't need to download anything. And then it works for them straight away. So it's better for this type of scenario. I would prioritize user need over your team need, but I understand there are different scenarios and different priorities in businesses. So if you can afford, I would rather keep progressive web apps for the use cases where you want the user to install it for a short period of time, skip the long download and installation step, and like just prioritize user need rather than the team need. That answers?
Yep.
Thank you. So I really like the part of optimization, whole assets and etc. But we know that the quota is limited, and someday we can hit the point that we won't have enough space to save our assets or some different object on our site. So do we have some strategy how to manage actually the quota or some resources inside them? So we could remove some different resources, maybe not even from our side, but from some, I don't know, old data that are there to save our new cache assets?
Sure. So generally, the quota is assigned per origin basis. So generally you can clean up your stuff when you need more space, but only your stuff. You can't clean other side stuff, obviously. And there are a few tips I can give here. One you've seen on the images example where I set max entries with the workbox library. This means that the workbox library takes care of, contains the code that will remove from the cache the assets that are older than something if it needs space for the new ones. And if you're interested in how to implement in detail, I think Workbox has it very nicely solved, so you can check the source code there. In Service Worker, also you have, there are API calls for the cache API that allow you to check. For example, if you do a fetch event and you want to add something big to the cache, you can always check what's the current, limit, as in what's the current storage taken and how much space you have. And if it's low, you can remove your old assets. Because it's not like HTTP cache. You actually have access. It's like a database, right? So you have access to all the entries and you can clean them. One interesting solution we used so far is sometimes we do something like app shell, which means you have critical resources on your app that need to download as fast as possible, or are really critical for the functioning of your app, probably the shell of the application, some CSS, some JavaScript. And then there are things that are nice to have, but not so important. For example, I don't know, chat widget or something additional, right? It's a good idea to save those things in 2 different caches under 2 different names. And then if you run out of space, evict those non-critical. You know that they're safe. If they're not there, it's kind of OK. You don't want to end up with the situation where you're very near your quota, and you need to refresh some really important resource, but you don't have space, right? And maybe the last thing is, again, this versioning. It's quite challenging in Service Worker to clean up resources when the new ones come. You need to know which ones are stale, which ones are not needed anymore. If you use something like Workbox library, you get it out of the box. So that's why it's one of the main reasons why I personally use that library. It allows me to version my assets, and it knows which assets are stale. So when I fetch, for example, new style sheet, it knows which previous style sheet it evicts. So I very rarely end up with stuff that I don't need in the cache. It's kind of always current.
So you're always remembering the last state of your cache, right?
Let me see if I can find it. So look at this. This is a Workbox precaching root. This part here, where I have a list with my logo, it's called manifest, caching manifest. Here I put it inline so that you guys can see, but it can also be a separate file where you list all the files you want to pre-cache together with the revision data, which is usually just a hash of the content. And Workbox has methods to generate this manifest for you automatically. For example, together with Webpack plugin or something like that, right? So then when you have a new build of your site, the manifest gets recreated, the new revision data is there, the Workbox receives it here, compares with the previous manifest, and say, OK, those are all the files that I don't need anymore. I can remove those, and I need to fetch those new ones. So generally, we do it via manifest.
What if you will store some resources from the API inside the same cache store?
Sorry?
Well, if you have your assets from the app that are critical, but you also do some dynamic caching for different resources in the same store, and you will compare that the new version of these critical assets with the old ones, and you see that some resources that are dynamically saved there are not in the new manifest.
Mm-hmm. Yeah, then you can remove them because you don't want. Oh, the dynamic ones.
Yep.
Then you treat them separately. That's why usually, if you do pre-caching and runtime caching, you store them separately because you know that you expect them to behave differently and update at different moment in time.
Cool.
So it's better to keep. And this is just you can have multiple caches per site. with particular name. So it just makes it easier to keep things separate.
Okay, so that's it. Thank you, Ewa.
Okay, thanks a lot, guys.